calculus is really all about computing rates of change. This is really important for economists because when we look at modeling decision making, how do people decide what to buy? How do firms decide how to produce a good or service? They're making decisions at the margin. They're looking at incremental change. Economists call this incremental change marginal change. I prepared a few exercises and slides to try and give you the opportunity to apply calculus to economics and understand a little bit better about how the computations that we've been performing help us understand and explain objects of interest. So if we look at question 1, it says compute the average rate of change on the interval of x from 2 to 4, and it's bounded including 2 and 4. So we're going from here to here, essentially. And this maybe seems a little bit familiar to you because it's going to be very similar to calculating a secant, right? So if we wanted to know what's the average rate of change as x changes from 2 to 4, we could do this in a brute force method. So let's use the brute force method. I'm just going to take f of 4 minus f of 2, and then I'm going to divide by f of 2. Now I haven't given myself a lot of room to write out all the computations, so why don't we take a little bit of a shortcut. I don't need to worry about the intercept there, so we can get rid of that. And we're going to have 4 minus 1 squared minus 2 times 4 minus 2 minus 1 squared. I shrunk things down just a little bit to give some more room. Then we're going to have plus 2 times 2. This whole thing is going to be divided by 4 minus 1 squared minus 2 times 4 plus 5. So we do need that plus 5 in the denominator, but I guess I could add it into the numerator, plus 5 and minus 5. They're just going to cancel each other out. The constant, the y-intercept, is just going to cancel itself out. And the answer is just going to be equal to 2. Now, we didn't really need to do those computations. We could have just looked at the graph. You can see that as we go up and over, we go up 4 spaces, and we go to the right 2 spaces, and 4 divided by 2 is exactly what we should have gotten here with our computation. And so the average rate of change is 2. Now, that's great. That was like a secant line we saw before. If we want to know the average rate of change, we can use this sort of brute force method and look at the incremental change that way. A second way to look at change is to use the instantaneous rate of change. So what if we made this x interval really, really small, right? That's what happened when we set h equal to 0. We made this interval really, really small. Now, if we already know the first derivative, and it's f prime of x is equal to 2x minus 4, then we know that f prime of x is going to be equal to 2 times 3 minus 4, which just happens to be equal to 2. And if we look at the graph where x is equal to 3 right here, it does look to my eyes like the slope there is equal to 2. In this case, the numbers worked out very nicely, and as we reduced that interval, we got closer and closer to this instantaneous rate of change. Now, the instantaneous rate of change, generally speaking, is only going to be accurate when x is equal to 3. As we move further away from 3, the slope immediately changes, and therefore so does the instantaneous rate of change. Let's look at a question that helps us better understand this concept of marginal increase. So here we've got a question looking at marginal cost. The question says a company produces cell phones according to the function C, which is equal to 1/2 times Q squared minus 4Q. Q being the quantity of cell phones produced. Compute the marginal cost of producing one additional unit using two different methods when the quantity currently being produced is 16. What two methods are we supposed to use? Well, we can use the methods that we used in the previous slide. We can use what I call the brute force method. And we can say, well, the cost of producing 16 cell phones is equal to 1/2 times 16 squared minus 4 times 16, which is equal to 128 minus 64. And so the answer is going to be 64. So if they produce 16 units, it costs $64. What if they produce 17 units? Right, so if they produce 17 units, we're going to have 1/2 times 17 squared minus 4 times 17. So we have 144.5 minus 68. And the total cost is going to be $76.50. What's the marginal increase? The marginal cost of producing one additional unit when the company is already producing 16 units is $12.50. Now what about using calculus? So let's use calculus. We can calculate the marginal cost by taking the derivative of the cost function let's just say we know that the derivative is Q minus 4. Well, what's Q going to be equal to? Well, I know that C prime Q, let Q be equal to 16. We get 16 minus 4 is equal to 12. The marginal cost, which is the slope of the cost function when quantity produced is equal to 16, that marginal cost, that slope is equal to 12. Now notice that there's a difference. Given the difference in our two answers, which number do you think is more accurate? The most accurate number is the brute force method, which might surprise you. But if you think about it, it makes perfect sense. This is the slope when the company is already producing 16 units. And you can see here, if we were to graph this out, the cost function is increasing. If I were to compute the instantaneous rate of change, also the slope, when the quantity produced is 17, what would our answer be? It would be 17 minus 4
Now, as I mentioned, it might surprise you that the calculus computation is not as accurate as the brute force method. But as we go forward in the course, we're going to learn some techniques to make this calculus method more accurate. Further, the brute force method, if you have a very complicated expression, it's going to be computationally so heavy and so difficult that it might even become impractical. For now, focus on these two different ways that we can calculate the marginal cost of producing one more unit. We can use the brute force method, calculate the two cost functions and take the difference between the two, or we can use calculus, find the instantaneous rate of change,